Hello class, today we are going to start a new chapter, that is electrochemistry. In this chapter we are going to study about electrochemical cell, how it is constructed. We'll study about the conductance, molar conductance, specific conductance. Then we'll study about electrolysis, and over here we'll discuss about Faraday's law of electrolysis, first law and second law, and the equation. After that we are going to see Nernst equation, and based on that we'll be doing the numerical. Now, electrochemistry is the branch of chemistry which deals with the interconversion of chemical energy and vice versa. That means the conversion of chemical energy to electrical energy and electrical energy to chemical energy is called electrochemistry. Electrolysis is the process in which the chemical reactions are brought about by the help of electrical energy, that is electrolysis. We have got two very important laws of Faraday's, known by a name known as Faraday's law of first law of electrolysis and Faraday's second law of electrolysis. We need to see the statement for this. So according to Faraday's first law of electrolysis, the amount of substance liberated at a particular electrode during electrolysis, we know the process of electrolysis is directly proportional to the quantity of electricity passed in the solution. So let us try to understand with the explanation. Say for example, if capital W is a substance get deposited at electrode on passing q coulombs of electricity, then according to the Faraday's first law of electrolysis, we can write W directly proportional to Q, that is the amount of substance liberated at a particular electrode is directly proportional to the quantity of electricity passed in the solution. And once again, Q, that is coulomb of electricity charge, is equal to current into time. So in place of Q we can replace with IT. So W equals to, when you remove this proportional sign, it will take Z into I into T. Now Z is known as electrochemical equivalent. It is a constant, it is known as electrochemical equivalent. Now when you just put I, that is current, as 1 ampere and time for 1 second, then this equation will be reduced to W equals to Z, that is electrochemical equivalent will be equal to the amount of substance liberated. Unit of Z, that is electrochemical equivalent, is gram per coulomb. So this comes from the Faraday's first law of electrolysis. Now let us see the second law of electrolysis. When the same quantity of electricity is passed through the solutions of different electrolytes connected in series, the masses of substance liberated at the electrodes are directly proportional to the equivalent masses. So this is the second statement. Once again we will try to understand this statement with the explanation. Say for example, if capital W1 and capital W2 are the masses of the substances liberated by passing the same quantity of electricity, and E1 and E2 are the equivalent masses respectively, then according to the second law we can write W1 by W2 will be equal to E1 by E2. And once again from the above equation we have got W equals to Z into I into T. So if you take W1, we can write Z1 into I into T, and similarly W2 equals to Z2 into I into 2. Now we'll substitute that value over here. So since I and T are similar, they will cancel and it becomes Z1 by Z2 will be equal to E1 by E2. Now when you just remove this equal to sign, we can put proportional sign over there. So equivalent masses is directly proportional to the Z, that is electrochemical equivalent. So since we have got E is directly proportional to Z, now when you remove that proportional sign we can put constant over here. The constant that is kept is F. where F is known as Faraday's constant, and it has got a value of 96500 coulombs. This is the Faraday constant value. Now on passing 1 Faraday, that is when we put the value for F, the quantity of amount substances deposited will be equal to 1 gram equivalent, that is W equals to E. Fine. Now there is a relation between the Faraday Avogadro's number and a charge of an electron, so which is given by the relation F equals to N into E minus. This is the relation, and from this we can calculate the Faraday's value. Say for example, Avogadro's number 6.023 in 10 to the power 20 into charge of an electron 1.6 in 10 to the power minus 19 coulomb. So when you just, so it will be come as nearly equal to 96500 coulomb, which is a value for Faraday's constant.